So next property is time reversal. First we write down the statement for this. So if signal x of t with period t0 is having Fourier series coefficient an, then the folded version that is time reversal of x of t will have Fourier coefficient an underscore n. So first we write down the mathematical equation for this. So if x of t, its Fourier series is an, then x of minus t, its Fourier series is a underscore n. So now we write down the proof for this. This question was also asked in exam, that is state and prove the property. Now we will write down the proof for this. According to definition of exponential Fourier series, then x of t is equal to summation n is equal to minus infinity to infinity an e raised to j2 pi nt by t0. This is equation number 1. Otherwise we will give continuous equation number 4, then 5. Then replace here variable t by minus t. So above equation becomes x of minus t. Summation goes from n is equal to minus infinity to infinity. An e raised to j2 pi n minus t. So it will be minus t by t0. Now here we put n is equal to minus m. Therefore x of minus t is equal to summation m is equal to minus infinity to infinity a of m e raised to minus j2 pi m t by t0. This is equation number 6. Okay, so compare here we compare comparing equation 5 and 6. So we can say Fourier coefficient of x of minus t is a of m. Okay, now what is its physical significance? The physical significance is the time reversal of signal in time domain corresponds to the reversal of Fourier series coefficient. So this is physical significance. So next property, time scaling. So first we write down the statement for this. It was also asked in exam. If signal x of t having period t0 is scaled in time domain multiplied by some constant a, then its Fourier series then its Fourier coefficient remains unchanged. So we will first we will write here a mathematical equation, that is, if x of t, its Fourier series is an, then x of at, its Fourier, it will be an. Now we write down the proof for this. Now here, according to the definition of exponential Fourier series, according to definition of exponential Fourier series, what is the equation? X of t is equal to summation n goes from minus infinity to infinity a n e raised to minus j 2 pi n t by t0, equation number 7. So here we replace t by capital t by at. So x of at is equal to summation n is equal to minus infinity to infinity a n e raised to j 2 pi, t is replaced by n a t by t0. This is equation number 8. Now we compare equation 7 and 8. By comparing equation 7 and 8, its Fourier coefficient remain as it is. Fourier series coefficient remain as it is. Now what is its physical significance? If a signal is scaled in time domain, then its Fourier coefficient remain unchanged, but each harmonic of the Fourier series is seen. So this is time scaling property. Next is frequency shifting. So first we will write here, it was also asked in exam. First write down the statement for this property. Frequency shifting of signal, frequency shifting of signal by n0 positions corresponds to multiplying the signal by e raised to j2 pi n 0 t by t0. So first we consider the signal x of t. So consider a signal x of t having Fourier series coefficient Cn. Then using exponential series, Fourier series, Cn is equal to 1 by t0 integration t2 t plus t0 x of t e raised to minus j2 pi n t by t0, equation number 9. Now suppose x of t is multiplied by e raised to j2 pi and 0 t0. We write here, suppose x of t is multiplied by e raised to j2 pi n0 t by t0, then denote it by y of t and consider, or let its coefficient is Cyn. So we can write this equation as Cyn is equal to 1 by t0 integration t2 t plus t0 y of t into e raised to minus j2 pi t by t0. So 1 by t0, it becomes c by n. 1 by t0 as it is outside, it will be t2 t plus t0. Now what is y of t? Y of t is x of t into e raised to minus j2 pi n0 by n0 t by t0 j2 pi n t by t0. So it is 1 by t0 integration t2. Here we take common e raised to minus j2 pi into 2 pi t by t0 into bracket n minus n0 into dt. This is equation number 10. Okay. So we comparing equation 9 and 10. What we get? Cyn is equal to c of n minus n0. Now what is the physical significance of this property? The shifting of signal in frequency domain by n0 positions corresponds to multiplying a signal in time domain by e raised to j2 pi n0 t by capital T0. Next is differentiation property. So first we write down statement for this. Consider signal x of t with period t0 if we differentiate x of t, then Fourier coefficient is multiplied with j2 pi n by t0, and its mathematical equation is, if x of t its Fourier series is Cn, then d by dt of x of t its Fourier series is j2 pi n by t0 into Cn. Now proof for it, this property. Now we write down according to the definition of exponential series. According to definition of exponential Fourier series, x of t is equal to summation n goes from minus infinity to infinity Cn e raised to j2 pi n t by t0. This is equation number 11. We have this equation. Now we differentiate this equation both sides with respect to t. So equation becomes d by dt of xt is equal to summation d by dt of summation goes n is equal to minus infinity to infinity Cn e raised to j2 pi n t by t0. So it becomes summation goes from n is equal to minus infinity to infinity Cn into t by, this is constant, so outside the integration, d by dt of e raised to j2 pi n t by t0. So it becomes summation n goes from minus infinity to infinity Cn into j2 pi n by t0 e raised to j2 pi n t0. This is equation number 12. Now we compare equation 11 and 12. So we write here, comparing equation 11 and 12. So d by dt of x of t its Fourier series is j2 pi n by t0 into Cn. So the physical significance of this differentiation property is, the differentiation in time domain corresponds to multiplying the Fourier coefficient by j2 pi n by t0 in frequency domain. So in this way we can prove this differentiation property.